So before we go and derive the essential requirement of simple harmonic motion and the various physical parameters of simple harmonic motion through physics as well as mathematics, it is better to have a look at the strange mathematical functions which repeat themselves after a certain interval. As you will recall that a function is supposed to be periodic if ft becomes equal to ft plus capital T. Means, suppose the displacement of a body is defined at time t as xt and the value of xt is a function of t, which could be ut plus half at square or whatever type of function described in terms of t. Then supposing after a time capital T, the value of the displacement, which is represented by x subscript t plus t, becomes same as ft, which means ft becomes equal to ft plus t, then this function is supposed to be periodic because it has exactly the same displacement at time t and after a time t plus capital T. Because this function repeats after an interval of time t, this t is called the time period of this mathematical function. Can we have some example of such functions? Well, the examples are actually many. One of the most frequently cited example is the trigonometric functions. All trigonometric functions are periodic. We'll take an example and see. For example, let us say the displacement of a particle is defined by x is equal to sine t. This is a familiar sine function. We know that the value of sine function repeats after an interval of 2 pi. For example, sine theta is same as sine 2 pi plus theta. Essentially, 2 pi plus theta is completing one revolution and going back to theta. If you recall the unit circle, if this is theta, then if you make a complete revolution and come back to it again, you cover an angle of 2 pi plus theta, and therefore sine theta is equal to sine 2 pi plus theta is equal to AB by OA. Sine theta is equal to sine 2 pi plus theta is same as AB by OA. In fact, you can even make a generalized formula in which you can write that sine theta is equal to sine 2n pi plus theta, where n is equal to 1, 2, 3, any integer. The function repeats after an interval of 2 pi. So, going by the same logic, x is equal to sine t is equal to sine 2 pi plus t, or rather sine t plus 2 pi. So you can see that the value of x repeats after an interval of 2 pi. For such type of mathematical function, the interval after which the value of the function repeats itself is called the time period of the function or periodicity of the function. So here we can tell that the periodicity of ft, which in this case is sine t, is 2 pi. Means t is equal to 2 pi, where t is the time period or the periodicity after which the function repeats itself. You know the graph of sine t. You can see this, that if sin t is plotted with x and t, what do you get? You get a curve like this, which again repeats. This is 0, this is pi, this is 2 pi, this is pi by 2, this is 3 pi by 2, which is pi plus pi by 2, 3 pi by 2, and the function repeats itself. This is the full cycle of the function. And this is 2 pi, which is equal to t. So you can see that at pi by 2, the value is 1, and at 3 pi by 2, value is minus 1. If you go on increasing the value of t further and further, it will not increase indefinitely. It will repeat itself after every 2 pi. So the form of this function will be here like this, and again it will repeat itself. Notice that when it is repeating, the maximum value of sin t, which is the displacement in this case, we can associate x in terms of, instead of pure mathematical term, we can tell that x is the displacement. It varies between 1 to minus 1. Recall that when the periodicity is bounded between a mean value, it is called oscillation. So in this case, x is equal to sin t is not only a periodic mathematical function, it also can represent oscillatory phenomena. In this case, the value of sin t moves between 0 to 1 and 0 to minus 1. And therefore, x is equal to sin t is not only a periodic function, but a function which is oscillatory in nature also. Now, just think of this for a while, that x is sin t is a periodic function. Similarly, x is equal to cos t is also a periodic function which repeats both these functions, both the above functions repeat after time or periodicity 2 pi. Now, what about a function like x is equal to sin nt, where n is an integer or n is some value, x is sin. Does this function also repeats? If we plot a graph, will this repeat? It will repeat. Why? Because you can say that if this function will repeat after a time period after time period 2 pi by n. Supposing t is time and x is displacement, we take this value of the displacement after 2 pi by n time. So, what is the value? If I put the question, what is the value of x after time 2 pi by n? After time 2 pi by n, after means after time t. So xt is equal to sin nt, xt plus 2 pi by n will be what? Just put the value of t plus 2 pi by n instead of t to get this value of the function xt. That will be sin n, and instead of t you put the value t plus 2 pi by n. What are you getting? You will get sin nt plus 2 pi. You know that sin theta and sin 2 pi plus theta have essentially the same value. So this is nothing but sin nt. So you see, the value of this function sin nt also repeats, but this repeats after an interval of 2 pi by n. So here the repetition interval is not 2 pi but 2 pi by n. So what will be the graph if we plot x versus sine nt, or if you plot a graph of x versus t? What will the graph look like? Let's see. The graph will look like something like this. This is the t and this is x. So let's make it a bit longer, this t. So what happens after 2 pi by n? So when t is equal to 0, x is equal to 0, and after 2 pi by n, so this to this is the repetition interval, and equal to 2 pi by n. So this to this is 2 pi by n. So what is this? This to this, half of 2 pi by n. That means this to this is pi by n. And what is this? This to this is pi by 2n. So the maximum value of x is when the value of t is pi by 2n. You put it here, you will get x is equal to sine n pi by 2n. This is equal to sine pi by 2 is equal to 1. So this is the maximum value 1. And this is the maximum negative value -1. So the function sine nt x is equal to sine nt. This function, if you plot it, again you get so this also is a function which repeats itself after 2 pi by n interval. So I can call this the periodicity of this function t is equal to 2 pi by n. And this also oscillates between 1 plus 1 to -1 with the reference point at 0. So sine nt also is a periodic function whose periodicity is 2 by n, call it time period, and whose value oscillates between +1 and -1. So not only sine t is a periodic function, sine nt is also a periodic function. Now the similar logic is given for cos nt and cos t. They are also periodic functions. What about tangent functions? The tangential trigonometric functions have a periodicity not of 2 pi but of pi. If you look at the graph of tangent, you will find that they repeat after pi. For example, the tangent function looks like this. This is 0. Let's say x is equal to 10t. So it is t, it is x. Then you will notice that at pi by 2 x becomes infinite, because this is equal to sine t by cos t, and at t is equal to pi by 2 cos t tends to 0, so 10t tends to infinity. So you mark it as pi by 2, then pi, then 3 pi by 2, then 2 pi. You will find that the function varies like this. At pi by 2, it becomes like this. At 0, sine t by 0. At pi by 2, it is infinity. Like this. And at pi, cos pi is equal to -1. So it becomes like this. This is correct. And then it again goes to like this, again comes like this, goes like this, comes like this, it goes like this. Is how the function repeats itself. This is a repetitive function. Tan t does repeat itself, but it is not unbound. It is not bound because at pi by 2 it reaches infinite. It becomes uncontrollable. It goes very high. So this is a periodic function, but not oscillatory function.